Now where we left off, we had these three tanks, tank 1, 2, and 3, and some rates going in and out, and they asked us to find a model for it. So we found this pretty model here, all colored up and nice, and we should recognize, and I forgot here this is the, oops, and this is kind of crucial, this is the derivative of this. And why is that important? Well, because now we recognize the above system as, so let me write it over here. We recognize the system as a vector, let's say x prime equals to a coefficient matrix times that same vector, not the derivative. So this is my a, this is my vector x, and this is the derivative of that vector x. Now, why is this important? Well, because if I guess that x is equal to k, a constant vector, times e to the lambda t, what's the derivative going to be? It's going to be lambda k e to the lambda t, because we said that k is a vector of constants, right? Well, then I can plug this stuff back in here and say k e to the lambda t and times lambda is equal to k e to the lambda t. So now I can cancel this because I know it'll never be 0. And now I have something interesting, and I forgot to write the a here. Okay, now I realize, hey, this is matrix multiplication, this is not. So let me include an identity matrix so that I don't change the value on the left, but that I can compare these two. And so this is what happens. Now if I subtract this from both sides, I get 0 is equal to a k minus lambda I k, for which I can factor out the k, which is just a vector of constants, and I get 0 is equal to, and this should be the 0 vector, is equal to a minus lambda I times k. Now this happens either when the determinant of a minus lambda I is equal to 0, or when k is equal to 0. But when k is equal to 0, that's not particularly important. And notice this is a scalar, this is a vector. So the zeros are a 0 scalar and a 0 vector. So this is what we're trying to solve. This is what they're saying. Solve this system using this. And we can solve it because that system has this form, which if we use this guess form goes all the way down to here, which ends up being, hey, I just need the eigenvalues of that A matrix. So now my eigenvalues are going to be my matrix. So let me put a square here. Actually, no, I don't want to do the square thing. I just want the matrix, but the vertical lines indicate that I'm going to calculate the determinant of it. And so I'm just going to do whatever I had over there minus lambda. So minus 3 over 10 minus lambda, and I probably have to make this larger. And 1 over 18 and 1 over 5, 3 over 10 and minus 2 over 9 minus lambda, and 1 over 10, and 0, 1 over 6, and minus 3 over 10 minus lambda right here. That has to be equal to 0. So I put it through MATLAB, and I should get some values. And then once we have the values, we can find the eigenvectors. 2 ways. We can either, well, depending on the case, we'll have to see. So let's just stop right here and let's go over to MATLAB. So we'll call this part B1. I know it's getting kind of crazy with the names, the titles, but this is how it is. So let's call this part B1, and I'll see you in MATLAB.